Okay, this video covers the different styles of rotors that are used in squirrel cage motors. It's Objective 4 in ILM 302B, operation of three-phase induction motors. So far we've looked at two main types of three-phase induction motors. The squirrel cage induction motor, which is the most common type of three-phase motor. And this motor doesn't give us great starting torque, but gives us really good speed regulation, which means from no load to full load, a squirrel cage motor does not slow down very much. As you add load to it, it only needs to slow down a little bit to give us quite a bit more torque. The second motor we looked at is a wound rotor motor, which does give really good starting torque, but does not have as good a speed regulation, which means it slows down quite a bit from no load to full load. And those are the two kind of ends of the spectrum for loads that we see. Some loads don't require lots of starting torque. Other loads do require quite a bit of starting torque. And what the manufacturers of three-phase motors found was that they could adjust the starting torque of motors by changing the design of the rotor. If a load required more starting torque than usual, you could get it from a specific rotor design. The motor manufacturers came up with 4 basic rotor designs that will change the amount of starting torque a motor can have and affect its starting current as well. The way the rotors are changed to affect starting torque is by changing either the size of the rotor bars or by changing how far into the core material of the rotor bars are down into that material. Changing either of these things will affect the starting torque and current of these motors. If we start with design A, we see that it does not have really high starting torque, but has pretty good speed regulation where it doesn't slow down much from no load to full load. Design A has a starting current of about 600% of the full load current. The starting torque is about 150% of the full load torque. So it does give higher than full load torque at startup. It is the most efficient rotor design we have of the 4. But although it is really efficient, it is not a common design because it has higher starting current than the other designs. Design B is similar to Design A in that it does not have a large starting torque again either, but has good speed regulation, so it doesn't slow down much from no load to full load. Design B is the most common rotor design squirrel cage motors have, so it is the most common style that is used. It has a starting current of about 500% of the full load current. Starting torque is the same as Design A, 150% of the full load torque. It is almost as efficient as a Design A rotor and has the advantage of a lower starting current. Design C is what is called a double squirrel cage design, and there are generally 2 sets of bars that are joined together in this style of rotor. Design C rotors have a starting current of about 500% of the full load current and a starting torque that is higher than Design A or B of around 225% full load torque. They are used where we have loads that need more starting torque and work well for hard to start loads that are not started frequently. Design D is the last rotor design we have. It is the closest in starting torque and starting features to a wound rotor motor we have, and has the most starting torque. It has a starting torque of about 275% of the full load torque, a starting current that's about 400% of full load current. It has a higher inductance, which helps to reduce the starting current. And because of the high starting torque, it is really good for frequently started, hard to start loads. Loads like cranes, pump jacks, and large pumps would start a lot better with a Design D style rotor. So Objective 4 compares the different rotor designs and helps you to see what the differences are in starting torques and starting currents. You could often see questions on a module test that come from this objective, and here's a couple examples that you could see. So here's the kind of questions you could see that come from the different styles of rotor design we have. The first question: a squirrel cage induction motor with rotor design A has a full load torque of 250 Newton meters. What would the starting torque of this motor be? All you need to know is to remember from the chart we have for the different rotor styles what percent starting torque a design A rotor has. And it has a starting torque of 150% of full load torque. So the answer is simply 250 Newton meters times 150% or 1.5, which is 375 Newton meters. Second question: a squirrel cage induction motor with rotor design C has a full load current rating of 56 amps. What is the starting current of this motor? Again, we just need to remember for design C what the standard starting current would be, and it is 500% of the full load current. So the starting current for this motor would be 56 amps times 500% or times 5, and that is 280. And the last question: squirrel cage motor with rotor design B has a full load torque of 40.5 Newton meters. What starting torque will it have? Again, from our chart, we know the design B rotor has a starting torque of 150% of the full load torque. So again, we would just take starting torque would just be 40.5 Newton meters times 150% or 1.5, which equals 60.75 Newton meters would be the starting torque of that motor. So it's probably a good thing to know for each rotor design what percent of starting torque you have with each rotor design and what percent of starting current you have with each rotor design, and it will help with any of these kind of questions that you see. Okay, hopefully that helped. That's it for now.